Okay, good day everyone. Welcome to my channel. Today, I am going to discuss text mining, keywords extractions, and keyword analysis. Okay, so our lesson objectives are as follows. Now, we have to extract multi-terms from the data frame, but the data frame will be read from CSV file. Just to explain with you the data set that we have. No? So these are this is a okay. These are research article now and has a total of 238 published research article of an academic institutions. So I just copy the title, the abstract, and the keywords of it. All right. So from there, no, um, our certain goal is to extract multi-term no, from the data frame and create keywords network analysis no, from this extracted multi-terms. No? Okay, so let me clear all the outputs that I have from this. So the first thing is to import the libraries. No? Okay, necessary library. You can also copy the codes that I have. Okay, and also reading the particular data set that we have. And next is checking the content. So we have the title, abstract, and the keyword. The next thing that we're going to do is to combine this in one row and in one column. Okay, and perform some pre-processing. As you can see here, I did not perform stop words removal, lematizations, steaming. It's because my goal is to extract multi-terms. Alright, so as you can see here, numbers, new line, apostrophe, and hyphens are some of the characters that we need to remove. So to check the certain output after that pre-processing, so here comes now the output. No? And it is not actually um, what you call this fit or probably can even view in this certain output. No? So later, we will be converting that into a CSV file to find and be able to have an output of this multi-term. So another library is a Spacey for building English language model. And there comes now the functions that we can use for extracting the compound terms. Okay, as well as uh, producing an output column on this. So another function to produce an output column or produce another data frame. So to check, we name that as df underscore rule number 2. So there you go. We have the output now of multi-terms. Okay. So some sort of checking the output percentage. All right, and it's too high as you can see. We have 95%. And once again, create another data frame for it's because our main format, as you can see here, is a dictionary. Okay, so here we need to remove this one and provide some delimiter which is comma. So there, for checking once again the output. So this one and right, creating this, checking the shape and correcting everything, and this one joining this together. So we have now the extracted multi-terms. Okay, and to check right away, so this is the main output of an CSV file that we would like to produce. So we have the original one and the output with the dictionary format and the multi-terms, extracted multi-terms. So I may run this to produce a clean.csv file and be able to save in output 3 folder. Alright, so checking the location. So we have here the clean.csv file and as well as output.zip. So what I need to do is to extract this clean data set. Okay, and this one, the clean data set, okay, has the original, okay, combined title, keywords, and abstract, and as well as the dictionary format. So I need to delete this one as well. And here comes now the terms. Okay, these are the terms already. So save it this way. So as you can see here, in the first research article, we extracted a total of 8 particular terms. So right now, we will also create ageless. So for example, let me open a Paint. So our next goal, this is our next goal. So let's say we have a total of 5 extracted terms from each paper. But the first paper that I showed to you is a total of 8. So I need this to create links. Okay. So from here, we have 1. Okay, so this is the particular output that we would like to produce. Okay, and this one. Okay, so yeah, a total of 10 for 5 nodes. So in this example, we have a total of 8 terms. 8. So our main goal is to produce a total of 28 ages from this. So don't worry about that one. It's because we need that in the certain graph like this. So don't worry for that. It's because I have created as a code which can read this clean CSV file that we have, and with the delimiter that we have now. Okay, which is the the split. It's because of the delimiter comma, and we're able to produce ageless samples. So to run, okay, and we have here ageless sample as our results. Alright, so this is what I'm trying to tell you earlier. So we have a total of 28 from that first paper that has 8 extracted multi-terms. So I need to insert for us to prepare into tools that we will be using. We can actually run and create a network using Python, but since we have the tools, so for now we will rely on the tools. Okay, so I will be using Gippy on this. So Gippy programming. Gippy tools. So this is an open source file. So all you need to do is to import that spreadsheet file. Okay, the name is ageless sample. Alright, so it was separated by comma before. Okay, so you may see to it that this is selected as comma here. I'm checking if there is certain problem. So I think we don't, there is no issue about this, and we need to append in an existing workspace. So as you can see, we generated a total of 3,037 nodes and 27,411 total of connections or pages. So as you can see, this is our graph now. Okay, so I may be using the available statistics methods here. Okay, I will be using network diameter to produce betweenness centrality, closeness centrality, and harmonic closeness and eccentricity distribution. So betweenness centrality is the, if you want, I will explain the next video. If you want this video, you can request. But betweenness centrality is more on showing the particular terms that has connections and can form other networks, or connected to the other terms. So betweenness centrality. And also for creating such group, so this just clusters. Okay, and a total of number of communities, that's too high. So you can actually create a total of, let's say, 5 here, and we can produce up 54 communities instead of 70. So let's say 15. 46. So as you can see here now, if you lower to get more communities, so a smaller one, or higher than 1.0 to get less. So what I did earlier is trying to experiment, trial and error, to produce a total number of communities from this. Okay, and filter, I will use this time degree range, meaning for those less connections to the other nodes will be removed in our certain visualization. Alright, so let's say you can just type here 40 for instance, and filter. So this is now our output. I will use also a certain layout, which is Frankerman, Reinhold, and run. Alright, so as you can see, we have now the created community here. So 1, 2, 3, 4. And since we have created this in to show our nodes, there's the large community that we have, another community here. Okay, so from here we can just provide a certain color to show the patterns. Alright, so you can all actually change the color. Okay, from here, let's say this is the number 1. Apply. Let's change this into something red. Alright, so it seems that this red ones is just connected. Okay, a total, the red ones compose of the large community or group, which is out from our, how many keywords that we have, I forget. Okay, we have a total of keywords, I think almost 3,000. So from this it creates our network creates this large group, meaning they group this, it's because they are somewhat related and somewhat used by other research articles, that particular keywords. Okay, so from this I may be using betweenness centrality. Go back to this. Alright, so just to show the certain results, you can actually check this one, decrease the particular label. So I think we missed something. Go back to our nodes here. All you need to do is to copy from ID going to the label. It's because we forgot to set some label. Okay, so as you can see, as I enable this one, automatically I can, I have here some sort of labels from our nodes. So for a simple data evaluations, it seems that this particular academic institutions, okay, is more, the research area is more on, let's find out this large network now. Okay, it's more on okay, water consumption. Okay, perform some experimental study. What else? Let's find out more about this network, no, or communities. Okay, so it is more on okay, iodine. Okay, it's more on a study related to some sort of pregnant women. Okay, salt. Okay, strict monitoring. We have also here known history. Yeah, they also baby boomers. Moreover, there are some sort of image processing, no? And machine learning is being involved in their study, and also they study so far about disasters, no? Disaster management, risk management, and this one I think this is about traffic congestion, no? Yeah, it's because of these keywords, MMDA and traffic congestions, as well as pattern recognitions, no? Let's find out more. They also have a research interest regarding computer security. It's because of this. And we can actually decrease. Okay, let's use a giant network this time, no, for some query. And for this topology, let's try to put here, no. All right, and run. You can actually set to use Portland Atlas and check about label adjust and no overlap. Yeah, this is okay. We have shrink, no, into a less number of clusters and nodes. Yeah, I think this is the optimal one. Okay, so that's it, no, for creating social networks. Okay, hoping you have learned a lot today. Thank you, everyone. See you in my next video.